this video, we're going to be talking about smart contract layout and how it's structured. So let's get into it. So one of the first things you're going to see on a smart contract is called the SPDX license identifier. So this basically tells you the license that is applied to the smart contract. And on the screen, you see an example. This one is using an MIT license, and there are many others. You'll see like GPL1, GPL2, GPL3, and there's a few others. Right, so this is basically saying that the code in this is open source and anyone can view it. And SPDX, as you see, it stands for Software Package Data Exchange. And this is what it looks like in a smart contract. So you see it's the first line, and this one is showing that it's an MIT license. And so the next thing is that you're going to see is the pragma statement. So the pragma statement is basically telling the compiler what type of compiler that was used to compile this contract. So every now and then there's a new compiler or a change to the solidity language that is what we call a breaking change. So this specific compiler would not be able to compile another code with a different solidity compiler denoted at the top. So that's what that stands for. Pretty simple, pretty straightforward. Usually what happens is you are able to compile other contracts. Say for example, we're working on a contract that is 8.10, right? In most cases, you're still able to compile it with a 8.17 compiler. But if it was 0.9.1, it would not work, because every time that second number increment, it means that there's a breaking change in the language. So, that compiler would not be able to cross over. But basically, it basically talks about the best compiler to use for this particular smart contract. So the next thing is a constructor. So this is a part of the smart contract that runs only one time, and the only time that it runs is when it is being deployed to the blockchain. So in this compiler function, it's basically minting 100 million tokens and sending it to the owner of the contract. And that can only happen once. So that's what that means. So this is an example of a smart contract. So you see here, let's make this bigger. So the first thing is the SPDX license identifier. This is using a GPL 3.0 general public license, and it's using a compiler of 0.8.4. So on line 4, you see where we start the contract. The contract is called coin. And in most contracts, usually you're going to see the public not the public variables. Let's just say variables for now. So you see the variables at the top. The first one is the first one is minter, and it is a data type of address, and the visibility is public. So that basically means that you can access this variable from outside the contract. You can access it from another smart contract, or you can access it from a Web3 application. The next data type is a mapping. If you remember the previous video, we spoke about mapping, so it's a reference type. So this is a mapping. This is basically saying keeping track of the amount of coins each user has. So where it says address, this is the address of a particular wallet, and this would be the amount that is stored or allocated for that wallet. And then you would read it like this. Let me find an example. Balances, right? So balances, it reads like an array. So you pass in the amount to the receiver, because receiver is an actual address. Then you pass in the amount. Then the amount goes into that little container or that record. which is here. So the amount just goes right into here. This is the receiver. This is the amount that the receiver has. So that's how you do mappings. And we're going to go over that in more details later. The next one is an event. So events allow clients to react to specific contract changes that you declare. So you declare the event, you call this event sent, and the first variable you get is from, so where it's coming from, where it's going to, and these two are both addresses, and the amount. And so this is a uint, which is actually short for 256. Me personally, I like to be explicit, but uint itself means 256, right? But when I write contracts, I usually write uint 256, but that's just a personal preference. But just know that that means 256, and there are others. There's 8, uint 8, uint 32, and yeah, so there are quite a few, but this means 256. So anyways, that is the event, and the way you use that event is like right here where it says emit. So you emit sent, you pass in the, what is that, from, let's see, from, yeah. So you pass in where it's coming from, which is message sender, which is the person that called this function, to the receiver, which is the person that you're sending the funds to, and then the amount that you're sending. So it emits that, and that is a record that's stored on the blockchain. So that's your emit. That is your event. So the constructor, this is what we spoke about earlier. So this only runs once. So once this code is deployed to the blockchain, it says message sender, which is the person that is actually, which is the wallet that is actually deploying this contract. You put that into Minter. You know, a lot of contracts call this owner also. So you could call it owner, but it's the same concept, right? Okay, let's continue. So the next thing is a function. We're not going to focus on what's actually happening in the function. I just want to talk about what it is. So a function is like an encapsulated piece of code that you can access to do a certain action. This is a public function, so it can be accessed from anywhere, from a Web3 application, from another smart contract, from another function inside this contract. So it's just completely open. And yeah, so that's a function. This is the send function also. Let's touch on this also. This is what you call a custom error. So let's read this. Errors allow you to provide information about why an operation failed. They are returned to the caller of the function. So this is called an insufficient balance, right? So you're going to get back the amount that was requested and the amount that's available. So let's see how that works. So right here in the send function, whoever is calling this function, this conditional statement right here is checking to see if the amount that they are requesting to send is greater than the balance that they have in their account. Remember, this was the mapping, this is the address. So we're checking to see if the amount that you're requesting to send, is it more than what you actually have in your account? If it is, if this is true, we're going to do a revert and we're going to call insufficient balance, which is our custom error that we designed. So insufficient balance, and then you're going to say this is the amount that was requested and this is the balance that I have. And in order for this error to be triggered, or this revert statement to be triggered, it is going to say that the amount is greater than the balance. That's the only way it would get triggered. So if this is true, this whole thing reverts and none of this happens. So that's a custom error right there. And yeah, so that's it. That's a basic layout of a smart contract. Obviously it gets more complicated from this point, but there's a lot more that goes into it. But these are just the fundamentals of what a smart contract looks like. and we're going to get into some more details later. So stick around for the next video. We're going to go into data types. We're going to explain what data types are, how to use them, and that's going to be an interesting video. So thanks for checking out the video. Like and subscribe, and I'll see you in the next one.